Are you ready? All right. Okay. Good. I'm online. Can you hear me? I see the screen clearly. Students online. Can you hear me? Can you see the screen? Oh, thumbs up means good. All right, cool. All right, let's do this paper. No, people have exams and all those things. So let us get through it quickly when you have exam again. You have exam tomorrow. Which paper you have tomorrow? English paper 2. So you want to go, you want, you know, if you study one. English soft, the capital T. English is soft. English is soft. It's our language. I joke, I joke, I joke, I joke. Let's do this quickly so you can go home and look over your stuff, right? All right, let's go. I want to know what grade you got on this paper. All right, so the first question here is to calculate this with a calculator and leave the answer as a fraction in lowest form. So that's a 3-mark question. Let's type this in the calculator properly. The fraction starting out with a mixed number, 3 and 3/8. Then we're subtracting another mixed number, 2 1/4. And then we're dividing that by another mixed number, 1.5. 1.5. And all we have to do now is make sure that what we have in the calculator is the exact same thing there. Let's make sure. And the answer is 0.75, which is 3/4. So the answer for this is 3/4. All right, and that's the first 2 free marks on this paper. Next question. Write this out and give the answer to 2 decimal places. So make sure you clear the calculator. Make sure you clear it properly. I want to make sure you get this right. I'm going to type this in the calculator again. So that is bracket 2.86 plus 0.75 is where I'm doing that. Oh, 0.75 close bracket. Then another plus. I don't know why they did that. 0.481 squared. That's what they have there. Make sure that's exactly what they type. Just double check it. That looks like it. I'm getting initially 3.841361. Terminates with an exact value, really, which it could be an exact value, but that's all addition. But I want us to correct the 2 decimal places. 2 decimal places. So these are the 2 decimal places that we are correcting. So using this one to correct that 84 or 0.84, it remains 0.84. And so for 2 decimal places, this becomes equal to 3.84 to 2 decimal places, to 2 decimal places. And that is it. All right, so that's your first 4 free marks on this paper. Next question. This question says, Paul bought and sold a computer. There's some consumer arithmetic. He wrote his business activity as follows. So the cost price for the computer is this. That's the amount he paid for it. $1,064. The mark price of the computer is this. The mark price is the price that is on it. Now, when you go in the store, I said the top, everything about price, tab on it, that's called a marked price. That's what the store intends to sell it for. But sometimes they can sell it for less, they give a discount, but most times they're always for less, right? To give a discount. That's a marked price. And here it says a discount of 5% is offered if somebody pays cash. So if you go there and pay them cash, they're going to give you a 5% discount. So if they give you a 5% discount, it means that you're paying 95% for it. because they're taking off 5% of the 100%. It says, what is the selling price when you pay cash? Selling price becomes 95% of the marked price. Right? The selling price when you pay cash, 95% of the marked price. So 95% of the 1390. That's what we're working with. 95% of 1399. 95% of 1399. And so we're going to pay 1329.05 if you pay for it cash. Some people calculate the 5% and then subtract it. So we get the same answer, same me. But we need to understand percentage like that. If you take off 5%, then it's 95% left. Suppose you were paying an additional 5%, they were paying 105%. Get me? That would be the figure you're paying, 105%. We need to understand percentage of this. We can get the answer quickly. And then what is the profit or loss as a percentage of the cost price? So the profit as a percentage, we need to know whether a profit or a loss. Now, the cost price is this, and they sold it for this. So the profit is the difference between these two. And then to get it as a percentage of the cost price, you're going to divide it by this cost price. So it becomes a profit divided by the cost price multiplied by 100. So see, you know, it's a profit. We know it's a profit, not a loss. But I sold it for more than the cost price. So the percentage profit is the profit over the cost multiplied by 100. What is the profit? The profit is the selling price minus the cost price. So it is the 1329.05 minus the cost price of 1064 minus the 1064, and dividing that profit, this becomes a profit. I don't have to show the actual profit, and just work it in there. Divide by the cost price of the same 1064. You get that as a percentage, you multiply this now by 100. And then work that out. You're done. So it's a fraction. 1329.05 minus 1064, that's a profit, divided by the same 1064, multiply that by 100. So it's a 24.9% profit. That is the percentage profit. By God, I guess they'll give it a mark. We put 25. Yeah. 25, they'll give it a mark. All right? But we must still practice to give our answer to 3 significant figures. 3 significant. All right? We put 25, they'll give it. Now, this question says, orange juice is sold in cartons of 3 different sizes. All right? Which size of orange juice is the most effective buy, or what they call the better buy? Justify your answer. So again, you want to know how much juice you're getting for $1 in each of them. How much for $1? That's what they want to know. How much you're getting for $1? I'm going to put it right here. We're going to put in a $1 color. A $1 color. $1. How much juice for $1? I'm going to put how much juice for $1. How you do it? But this amount of money, that's that amount of juice. So you're going to divide this row. You're going to divide this row. You're going to divide this row by the money to get it up to 1, the 4.2. You don't want to know how much for $1. Right? So you divide, this is for $1. How much for $1? All right, so I'm going to divide this row by the 4.2. I want the money to become $1. So divide by the 4.2. So divide everything by 4.2. This becomes 1. And when it becomes 1, you're going to see the amount of juice for $1. So you divide this row by 4.2. All right, so you're going to say 350 divided by 4.2. You get 83.3. So for $1, it's 83.3 milliliters for $1. Right? Then this one now, this amount of money for this amount of juice. So you want to know how much for $1? You divide by the 5.35. Get it down to $1. And divide by the 5.35 as well. I want the money to become $1. So this row I'm going to divide by 5.35. Divide this row by that. Divide this row by 5.35. So that the money come down to $1. So when the money come down to $1, what does the juice come down to? So you divide the 450 divided by 5.35. I'm getting 84. So I'm getting more juice in the second one than the first one. 84.1 milliliters of juice. Then the last one now is this amount of money for this amount of juice. So you want to know how much for $1, you're going to divide by this, the $5.80. So you're going to hit this row and you're going to divide by 5.80. So it's 4.20. To get the money down to $1, you divide it by 5.8, you divide it by 5.8 as well. So it becomes 500 divided by 5.80, and you get 86. You get 86.2 mil. So this is the better buy. The last one is the better buy. Getting more juice for your dollar than the last one. This one is the better buy. The last one is the better buy down here. You're getting more juice for your dollar. Understand that? So all you have to do with this, always bring and say how much you getting for $1. Or you say how much you getting for $1, divide by the month. And you see how much you getting for $1. Right? The one that you're getting more of for $1 is your better buy. So I'm getting more in the third one. So you're gonna say 500 mil is the better buy. It's the most cost effective buy, same thing. Sometimes just call it better buy. Because we're getting more juice per dollar, per $1. More juice per $1. That's the reason. And your calculation is here. You put this by leave this on the exam paper they give you a max. You have justified what you did. I show that you divide each row by those $1. This is what the $1 is. And here I put for $1. How much juice for $1? That is it. All right, let's continue. Question 1 done. Number 2 is to factorize this thing. So this is the two terms, the difference of two squares in it. But when you have a common factor, you do the common factor first. Always do the common factor first. When it has a common factor in it. In this case, the common factor is 4. So you factor out the 4 first. Out of this, I'm going to have a squared minus out of this, I'm going to be left with a 4. We have to know that this 4 is a perfect square. The square number. The same as 2 squared. So this becomes 4 into a squared minus 2 squared. Then inside here now, we have the difference of 2 squares. So apply the rule for the difference of 2 squares inside the bracket and don't throw away this first factor 4. Keep that first factor 4. So you get 4, bracket, 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 bracket. First, you're going to have the a minus 2 and then the a plus 2. Everybody must remember the rule for the difference of 2 squares now. The difference of the numbers and the sum of the numbers. All right? And that is it. Done. Next question. I want us to factorize this now. Let's go through the process. Long time we don't go through the process of splitting this middle value. All right, let's do it. So to split that middle value, you're going to multiply the two n coefficients first, which is the 3 times the negative 8. Made the pen thinner. 3 times negative 8. So, right, so we're going to multiply the 3 times negative 8, and that's going to become negative 24. You want a factor of negative 24 that add to the middle term, the middle coefficient of positive 2. Positive 2. So you're looking for factors of negative 24 that when you add them, you get negative 2. If you don't see the 2 factors, that is 6 and 4 right off the way, right off the bat, then you can search until you find the 2 factors. All right? So let's say searching for factor. You have to start with 1 and the number. So let's say if you try 1 and 24. Remember now, because you want a factor of a negative number, one factor must be positive and one factor must be negative. This is a negative number. So one of these must be positive and one must be negative. You make the larger one have the same sign as this. Because you want the sum to be positive. So you make the larger one positive now. Put the plus on this one and the minus on this one. But when you add these two, the 24 minus 1, you only get 23. So you cross it off, you don't want 23. So you go to the next two factors of 24, which which is 2 and 12. But the larger one positive, the smaller one negative. But 12 minus 2 is 10. You don't want 10, it's 2 you want. So you cross that off. You go to the next two factors, which is 3 and 1. 3 and 8. The larger one positive, the smaller one negative. But 8 minus 3 is 5. This equals 5. You don't want 5 either. It's 2 you want. So you go to the next two factors. 4 and 1. 4 and 6. Large one positive, smaller one negative. Then 6 minus 4 is 2. So yes, you have found it. You have found the two factors of negative 24 that gives you 2 when you add them. So you're going to split this 2y into minus 4y and plus 6y. 6y minus 4y, same difference. All right, that's how it works. So come now, I want to split this now. So this expression now, this expression here, split the middle term, we're going to get a 3y squared comes back. And this 2y becomes 6y minus 4y. 6y minus 4y. Though I could put the minus 4y first, then you have a minus 8. They have divided, break it out into 4 terms. So now you can factorize by parts, factorize those 2 and factorize those 2. So look for the highest common factor in the first 2 terms. Highest common factor in the first 2 terms right now is 3y. So factor the 3y. Out of this factor, you're going to be left with a y. Out of this factor, you're going to be left with a plus 2. Remember, you must have the same thing in the bracket over here. Y plus 2. So I normally just write it back first. Y plus 2. And then in between, you must have a plus or a minus value. Not just a value, plus or a minus value. And you can know that value is by saying, okay, this negative 2 divided by this negative 8 divided by the 2 is negative 4. You know what that factor is. Or you can divide this negative 4y by the y, and you take it out here than negative 4. So that's a negative 4, not just a 4. And if you're not sure, you can check it. Minus 4 times this y gives you about that. The minus 4 times this positive 2 give you back that negative 8. So you know you factorize it properly. Then what happens now is that the y plus 2 and the y plus 2 is a common factor, and they are connected with the y minus, with the 3y minus 4. And so you're going to write the 3y minus 4 times the common factor of y plus 2. And that is your answer when this is factorized complete. Very good? Nice and easy. Now I want us to solve this pure simultaneous equation. Okay, it's an elimination method. We can make the 2y values of the same size, one positive, one negative. So we'll add them, they eliminate each other. So I'm going to adjust this equation and make it have a 2y on it by multiplying this equation by a 2. I'm using the elimination method. When I multiply that first equation by 2, it becomes 4x plus 2y equals 6. This equation, I'm not changing anything on it. I'm leaving it as it. So I'm just going to leave this one as it is and put it back as 5x minus 2y equals 12. When I add up everything on this side, the 2y and the minus 2y will eliminate each other. So it means that I'm going to add these two equations now, add them to eliminate these. When I add the 4x and the 5x, I get 9x equals, when I add these two, the 6 and the 12, I get 18. Remember, when I add these two, they are eliminated. And to make y, to find x now, just divide by the 9. 18 divided by 9 is 2, so the x equals 2. In order to know that x is 2, you can take this x equals 2 and substitute it back in this one right here to find out what the y is. So I'm simply gonna say, and 2 times, and let me show what I'm substituting, and 2y plus 2x, not 2y, 2x plus y was equal to 3. So 2 times 2 plus y is equal to 3. I will put the 2 here so for the x. And then the y equals 3 minus 4. Because this 2 times 2 is 4. And I bring it over and subtract, you get 4. And so the y equals -1. Therefore, your solution is the point 2, -1. Or you can write x equals 2, y equals -1. That is it. Right? That's the solution, right? Very good. 5 marks are doing that. Nice 5 marks are taking it. All right, next question. That's a variations question. So table below shows corresponding values of variables x and y, where y varies directly as x. Y varies directly as x. It means that y is equal to a constant times x. What does that mean? And all I want us to do is calculate the value of t and u. They're not asking for the k. You can find the k if you want, but you don't have to. Now, what you can do is express k as the subject by dividing by the x. So the k equal to y over x. It means that y over x is a constant all the time. Right? Y over x is a constant. But if you want to find the k first and get the equation, you can also do it that way. Get me? But y over x is a constant. So we can do it that way. So okay, y over x is a constant. A constant is y over x. Y over x is a constant for any pair of value. That's what we use it. So this y over this x equals this y over this x. I can say this y over this x equals this y over this x. Right? So see there? You can say the u over 10, that this y over this x is equal to this y over this x, which is 3 over 6. Right? And you can take this 10 now and multiply it up here. So you can say the u equals 3 over 6 times 10. So the u equals 5. And then the other pair now, the other pair, this y over this is equal to the same 3 over the 6. So you can say 9 over t, that y over that x, is equal to 3 over 6 again. I know you're trying to find the t. You must realize that's a half, right? That's a half. So in order for this to be a half, this have to be 80, don't it? It have to be 80. But if you work it out, this works out to be a half. So we can multiply the t, divide under the 3, multiply of the 6, cross multiply. So if we do that, we'll get t over here, so equals 9 times 6 over 3. And the t going to be 80. T equals 80. But if you realize that the ratio is always a half, see, this ratio is a half. The y over x is a constant, right? So look at what this y over x is. This over this is a half, right? So the value here is always half of this value. So that is it. This value is half of this, so it must be 5. And this value is half of this, so this must be 18. It's not complicated. All right? So we can do it without finding the k. Realizing that the k constant, or y over x is a constant for all the pairs. If you do it by finding the k first, that's fine as well. Right? But those are the values. What good? All right, so u equals 5, t equals 10. T equals 18, not 10, 18. All right, let's continue. Number 3. It's a Venn diagram. Remember, you're getting sets on paper 2, not on paper 1. You're getting sets on paper 1, not on paper 2 in your exam. You're not getting sets on paper 2, only on paper 1. So we're going to have to do a class, we'll do a lot of sets. So we start when the first exam done, we'll start do a lot of practice of multiple choice, we do some sets like that, right? Diagram below and sets about 6 to 8 sets questions on the multiple choice paper. I forget them right. The Venn diagram below shows the number of students who study history and French in a class of 30 students. So when I'm telling you that a class of 30 students, I don't want to forget. I'm going to put 30 out here. So everything in here so must add up to 30. And so like we have 5 or so, then you add up to 25. But everything must add up to 30. All right, that's what it says. Write that expression in X in the simplest form for the total number of students in the class. Write an expression about the total number of students in the class. So everything here, so you're going to add up representing the total students in the class. So that would be 18 minus x plus 14 minus x plus 5. But understand that. Good? And say that expression, I'm going to say, i.e., that is, let's consolidate. So this x and this x, they wipe out each other, so only have a minus x left. Let's look at the numbers first. So it's 18 and 14. How much is that? 18 and 14 is 32, right? That's all. I'll put it this way. This is 14 and 5. That's 19. So it's 18 and 19. How much is that? What is that? What is that? 37, don't it? 37. So it becomes 37 minus x. The answer is 37 minus x. Right over here. 37 minus x. This becomes 37 minus x. All right, that is the answer right here. What I got to that? 37 minus x, right? All right. Next question. State whether the following relations are true or false. H union F is equal to the universal set. Is that true or false? Is this true or false? Now, H union F is everything inside here. Universal set is 30, so that can't be true because there's a 5 outside here as well. See that? That is false. So this is false. Because H unit F is just inside here. H unit F is actually 25, not 30. Next one. What does this mean? H intersect F complement. You know what this means? This means inside H, but at the same time outside of F. So it means that H only. This means H only. And let me write out what each of these mean. So this, I'm right over here. So this is the union of H and F. Union of H and F. So it really means H or F or both. That's what it means. And that's not the universal set. Right? That's what that means. And then this one now, this one means H only. That means you're inside of H and you're at the same time outside of F. So if you're gonna be inside of H, means that inside here, no, but at the same time you want to be outside of F. You want to be outside of this. So you're gonna be in that blue section and at the same time outside of that red section. It means that you're only inside here then. That's where you want to be. That's H only. See that? You're outside of the red. That's what F complement means. And at the same time, you're inside of the blue. It means that you're inside here, which means H only. So this is a symbol or the set notation for H only. So this means H only. And this means empty set. This means an empty set or a null set. This means empty. So this also is false, don't it? Because we have values in H minus F, don't it? So this also is false. So the two of them false. Both of them false. Because it's not empty. H only is not empty. All right? Next question. Determine the number of students who study both history and French. Both history and French is X. This is asking for X. See that? That's asking for X. So we're going to find X. We know the total number of students is actually 30. That's what we know. Total students is 30. That's what we know. So we're going to say, okay, remember that the total equals 30. So it means that 37 minus X is equal to 30. 37 minus X is equal to 30. The 7 will be, the X will be 7, don't it? So the x equals 7. That is the answer. That is the answer for this. 7 is the answer. That is the answer. Student who study both. All right, done. Next part wants to do this construction. Use a ruler, pencil, and a pair of compasses. Only construct triangle PQR. Let's sketch it out and then we construct. Sketch it, then we construct it. So we must have a line PQ, and it must be 5 centimeters. Then the angle at Q must be 60 degrees. So over here must be 60 degrees. Like so. So inside here must be 60 degrees. And then the angle at P must be 90 degrees. So we need a 90 degree right here. That's what we're constructing. See that? See it? So sketch it and then you construct it. Sketch it and then you construct it. All right, let's go. Let's construct it over here. All right. So just sketch what we're going to construct a while ago. Let's get over here start again. So it's sketching. This is 5 centimeters. This is 60. This is 90. That's all we're sketching. That's all we're constructing, right? Sketch it and then you construct it. Ready? So I'll do the 5 centimeter line first. So we're going to draw the 5 centimeter line first, right there, with the ruler. Move the ruler out of the way. We're going to construct at 90 degrees at one end. Let's construct at 90 degrees at this end. Hold your compass a reasonable length, a reasonable diameter, a reasonable angle. When the construct 90, remember we do a 120 and break it into 60-60. Right? So construct a big 120 over here. All the way over there. And then move the point to here. You cross the first arc, with the first arc there, that's 60. Come up to this intersection. And then cross the second one. That's a second 60. So we have two 60s. We need to bisect the second 60. So you come to this end of the second 60. Rotate it up here. Make an arc. The top above there. So over to this end of the 60. Rotate the compass again. Cross that one. So the straight line through that intersection now is going to be 90. Let's come over here now and make a 60-degree angle right here. Let's change the color for the 60. So right here now I'm going to make a 60-degree arc. Cross this one, rotate that up to about 60 up there. So come to this point, and then rotate and across that one. That's a 60. So you draw the line now. So the straight line up here to this intersection is going to be 90. And then the straight line through the intersection for the 60 up here. So that first line should have gone up further. See it? At 60. Let's extend what the first one. Through the intersection and extend it all the way up. It's trying to go to the end of the line. It's trying to go to the end of the line. So maybe I need to just draw it. Something like this. And label it. This was P Q R. This is 90. This is 60 degrees. That is it. Alright, something like that. Let's copy this, put it over there. Something like that. Then them say, measure and state the length of PR. I want us to tell them the length of PR. All right, remember down here says 5 centimeters. That's right. Remember this is 5 centimeters down here. So I don't want the length of this side PR. Go back on the diagram and see if we can get it on the arm and the drawing. PR. So we can open the compass. I can put the ruler against it. Let's see if the compass can do it. Can stretch so far. Yep. Right about there. So let's put this against the ruler now. Let's put this against the ruler. Measure it against the ruler. That looks like about 8.6 centimeters. 8.6 centimeters. On the right, 8.6 centimeters. So I'm getting 8.6 centimeters for that length. Next one, the measure of angle PRQ. Everybody know that is 30 degrees, right? At a right angle triangle, it has to be 30 degrees, don't it? 30 degrees. Let's see what we actually measure. So you're coming up here, rotate it around this way. So come up at the eye of the point right there, rotate down to, rotate, make sure your baseline pass through 0. Voila, right in the 30 degrees. You see that? See it? 30 degrees. Baseline pass through 0. 30 degrees. It? You read the 0 scale. Reading the 0 scale right here, so. Right here, so. Read that scale. Right? You can say I pass through the 30 degrees. Right there. That line. So this angle is 30 degrees. This angle is 30 degrees. All right? That is it. All right, so that's 30 degrees. All right, that is it. That finishes that question. Next question. So this question said, diagram below, not drawn to scale, shows a silver box with no lid. There's nothing on top, so it's open. Silver box with no lid. It said the sides and bottom of the box are 1.5 centimeters thick. 1.5 centimeters thick. Calculate the volume of the box using the external measures. So the one external measures. So this one, and this one. That's the external volume. All right? External volume. Let's call it that. Volume externally becomes 30 times 20 times 15. How much is that? Something centimeters squared. 9,000? 9,000 cm cube. And she put the cm cube on it. All right. Next one. That's right. Next one says, complete each of the following statements. It says the internal length of the box is 30 minus 2 times 1.5. Anybody can tell me why it's minus 2 times 1.5? Because this is the length of the box, internal length. They're talking about this, look. They're talking about internal length this way, look. That length they're talking about. Huh? What -3? Huh? Now the question says, what is the internal length of the box? And they give us a quick calculation for it. And they say it's 30 minus 2 times 1.5. So it's 27. No, it's 27. But why is it that this is the formula? To calculate the length. But remember, the thickness of the material is 1.5, right? So right here, so is 1.5, and right over here says 1.5. See that? And externally, it was 30. So you have to subtract the 1.5 and the 1.5. You have to subtract the 1.5 2 times. See that? But that's not that. Good. So that's why that is the length of the box. How much you work out to? 27? So this is 27, right? 27 centimeters. The length. Remember that the thickness is 1.5 cm. Then this one now, the internal width of the box now gonna be what? Gonna be what? Internal width of the box that across here now, it's a different color. It's across here, so now. That width across is gonna be what? What's the calculation for that? It's gonna be 20 minus 1.5 and 1.5 again. See that? 20 minus 1.5. So that's 20 minus 3, that's 17, all right? So that's gonna be 17. So it's gonna be down here, leave it in purple. It's gonna be once we say it was again 20, right? 20 centimeters minus 2 times 1.5 centimeters, which becomes 17 centimeters. That is it. Then the depth of the box is what now? The depth of the box is gonna be what? Who can tell me the depth now? Let's put that part in blue. The depth of the box is gonna be what? That's down here, son. Down here, so. Internal depth of the box. Let's put it right here, so. What's that gonna be? We're gonna report that depth. I'm gonna say don't have no lid in it. What's it gonna be? Pay attention, man. We're gonna get that. The external dimension is 15. You have to subtract the thickness down at the bottom of the box right here, so now, see that? So it's 15 minus the 1.5 one time alone now, see that? Because the box has no lid, right? So it becomes 15 minus 1.5 is how much? So it becomes 13.5. So this one becomes 15 centimeters minus only 1.5 centimeters. Becomes 13.5 centimeters. That becomes the depth of the box. So these are the internal dimensions of the box. Those are the internal dimensions of right. That's one in the red. Those are the internal dimensions of the boxes. 27 centimeters. All right? Internal dimension. It says calculate the internal volume. So it's an internal dimension. So the volume internally becomes, what is it? 27, 17, and 13.5. 27 times 17 times 13.5. What are we record to? 27 times 17 times 13.5. That's 619, 6.5 centimeters cubed. That's the internal space in the box. The volume of the space in the box. All right? Question says no. The box is made of silver. Remember, it was a silver box. The box is made of silver, which has a mass of 10.5 grams for each centimeter cube. What that means is that 1 cm cube of the box, of the material that makes the box, is equivalent to 10.5 grams. It says calculate the mass of the silver used to make the box. The mass of the silver, calculate the mass of the silver box, giving your answer in kilograms. So this statement right here so is this. So look now, let's think of it, guys. The external volume of the box is this, 9,000. And the internal volume, which is the space of the box, is this volume. So the volume of the material in the box, now, the bones and the sides of the box, must be the external volume minus internal volume, don't it? So the volume of material in the box, let's call it material, the volume of the silver there. The volume of silver must be equal to the volume externally minus the volume internally, don't it? Which was 9,000 minus how much? 6196.5, which is what? Let's work it out over here. Give me digits. 2 what? 0.5 cm cube, right? But to get the mass now, since 1 cm cube is this grams. No, I'm not going to divide, I'm going to multiply. If 1 cm cube is this, I'm going to know how much 2,800 some cm cube is. When I multiply by this, so that's all. We may get in a grams, right? Right. So I'm going to say now the mass of the box then. We make this small. So what I said, therefore, the mass equals 2803.5 times the 10.5 grams. See that? And I wrote that out. So I multiply this now by 10.5. So it's 2803.5 times 10.5. So I'm getting 29,436.75 grams. But I want kilograms. So I divide by 1,000 to get kilograms, right? So to get kilograms, divide by 1,000. So you're going to move decimal point 1, 2, 3 places to the right. So you're going to get 29.4 kilograms if you're giving it to 3 significant figures. And that is the answer. But understand that? Divide by 1,000 to get it into kilograms. That's the mass. But all right? Very good. And now I get it, you want to work it over. All right? Like certain kind of question here. One here, them set up question about a trough. Same kind of thing. External volume minus internal volume equal the volume of material. All right? If you have a cup, I want the volume of material in it. Then the external volume of the cup minus the internal volume of the cup, leave with the volume of the material we make the cup. All right? They like to set this external minus internal volume thing. They set it all the time. All right? So let's go. Next question. Number 5. Number 5 gives us this diagram with 2 parallel lines. So once you see parallel lines, guys, and they are connected with other lines, you're looking for Z angles, you're looking for U angles, you're looking for co-interior angles, and so on. You're looking for vertical opposite angles. Like, for example, these 2 angles are the same. Vertical opposite on that cross. Right? These 2 angles are the same. This one and this one are the same. Vertical opposite, they call those. All right? Then this one and this one are the same. Correspond because this and this line parallel. So this line here must interact with the 2 blue lines the same way. That 1 red line must interact with those 2 parallel lines the same way. And therefore, for example, this angle over here, so which is x over here, so then over here says x2. Stuff like that. All right. Then another thing now, these 2 angles must be there. No, they're not parallel, so not you are. Not you are. These 2 angles are up to 180, this and this. But there are no angles inside this U. So up the parallel line, up this side and back up this parallel line, these are 2 angles in the U. Call them co-interior angles. They add up to 180 degrees. All right, because you have these 2 parallel lines here. All right, so we look out for these two. But let's answer the question. Question says, diagram below, that drawn to scale shows two straight lines, JK and JL, intersecting a pair of parallel lines. These are the parallel lines. All right, and it says, determine given reasons for each of your answer, the value of X, the one X. Now for X, it's kind of simple. You can say total angle in a straight line is 180. So this angle becomes 180 minus 120, right? Because the total angle across is 180, don't it? So the X equals 180 degrees minus 128 degrees. Well, you don't need a degree. If I say the X has a degree on it. So the X don't have a degree on it. The X is not an angle. The X is just a value, right? You don't need degrees. I'm going to leave out the degrees. X is just a value. See, that's for the value of X. The value. What is your work out to? 52. So X equals 52. So the angle is 52 degrees, but the X is 52. But that's not X is 52. Next angle I want is the Y. Now these two are just add up to 180, don't it? Co-interior angles. See that? But see that? Co-interior angles. So the Y, or you could say this as well. The Y equals 128. That's what we call corresponding angles, right? Two angles, they interact with this straight line the same way because these two lines parallel. So the Y is 128. They are corresponding angles. So the Y equals 128. Oh, here would say total angle of straight line is 180 degrees. Total angle on a straight line is 180 degrees. That's a reason. That's supposed to give a reason, right? And down here now, we're going to say the Y equals 128 degrees. That's corresponding angles are equal. The corresponding angles are equal. They are corresponding angles. The Y and the 128, they are corresponding angles. They don't want the angle W now. The angle W. All right, we're going to get the angle W. We have to calculate it. You get the angle W. You can come and work in this triangle right here, so. And we can see, all right. This angle here, so let's work it out this. We can say this angle is also X, right? Same as this one, that's all. Right? So this angle is also X. So this angle is X. And this angle is 80 degrees. But answer why that's 80 degrees? Straight line, 180. And you saw 100 already, don't it? See that? So the double then comes 180 minus them 2 here. What is the X again? The X was equal to 52, don't it? So this angle is X, which is 52 degrees. And therefore the double becomes 180 minus the 52 and the 80, don't it? But I can say that working in this triangle up here, so total angle in that triangle is 180. All right, so I believe this marking on the exam paper to you know, so show the examiner how get to answer. And then someone show the working. So the double becomes 180 minus the sum of the 80 and the 52. What I work out? It becomes 100 minus 52. What's that become? 148, right? 48. So the double is 40. The angle is 40 degrees, but the double is 40. Can I say double degrees? So the double is just 40. And them three angles they must add up to 180. This, and this must add up to 180. So them two add up to 100, and they add the 80, make 180. So the double is 48. Very good? All right. So what we do for this one now? Total angle of triangle 180, right? Total angle in a triangle is 180 degrees. That's what we use. Total angle of triangle is 180 degrees. All right. Done. Next one. This one says diagram below shows triangle RST and its image R prime, S prime, T prime after a transformation. That's a translation. See, it's got to this without turning, no change in size, no change in orientation. Just the same shape, everything, right? You can see it. That's just a translation, guys. I just need to count how many units to the right and how many units down. Obviously, you got down, right and down, right? So you can look what happens to point S. Let's look what happens to the point S. So point S goes 2 units to the right and 1, 2, 3, 4 units down. That's -4. That's a +2. See it? So translation 2, -4, right? Translation 2 units to the right, 4 units down. So it's a translation two units to the right and 4 units downwards. Given by. If you stop here, so they give you a marks, you know. Stop this, so they give you a marks. We're gonna say given by the matrix 2, -4, 2, -4. So that's a matrix for me, translation matrix, 2, -4. Very good? All right. Next question. It says RST is reflected in line x equals 6. It says on the graph, draw a triangle R double prime, S double prime, T double prime, the image of RST after the reflection. And I must write on the coordinates of the point R double prime. So I'm going to reflect in the line x equals 6 now. X equals 6 is a vertical line passing through 6. See it here, so? I'm reflecting that line. Let's draw it blue. So a vertical line passing through 6 this way. That is the line x equals 6. I'm reflecting in this line now. So reflecting in that line. Image distance equals object distance. So S is 1 unit to the line, it's gonna go 1 unit on the other side to here. So S is coming here. So that point is S double prime. That's S double prime. Then R now. R is 1, 2, 3, 4 to the mirror line. It's gonna go 1, 2, 3, 4 on the other side to here. So R is going all the way over the field. That's a R double prime. Then T the same thing. 1, 2, 3, 4 to the mirror line. 1, 2, 3, 4 on the other side. Just here. That's where the T is going. That's T double prime. Now that you have all those points, you just draw the triangle now. That is it. All right? That's it, the triangle. It's about to write the coordinates of R. Let's put it beside it here. So R is the point 10. What is that? 10, 3. 10, 3. R is the point 10. What can I say that? 10, 3. R is the point 10, 3. So R is the point 10. R double prime point 10, 3. But I got all right, beautiful. Let's just stand there. Let's continue. Like this kind of question, I give it a grant. Don't get the calculator. Question said, diagram below shows a graph of a straight line x plus y equals 3. So cross y-axis at 3 and cross x-axis at 3. X plus y equals 3. He said, determine the equation of a line which is parallel to x plus y equals 3 and passes through the origin. That's going to be x plus y equals 0, don't it? That's going to be another x plus y line. So if we parallel to it, it's going to be another x plus y line. Right? And those will pass through the origin. Remember, x plus y equals n. Our lines x plus y equals n. Our lines will cross y-axis at n and cross x-axis at n. Like so. Like this one, for example. The cross up here is at 5. The cross is at 5. So it's x plus y equals 5. So you pass through the origin. It's still parallel to the x plus y line. But now the n is 0. Balance on that. So it's just x plus y equals 0. All right? X plus y equals 0. So it's going to be x plus y equals 0. All right? Remember your lines like this and put a little sketch. Lines like this. Lines go like this. Pass up here so at n. So pass up here so at n. Pass on this at n. Then this line is x plus y equals n. So you pass through the origin. Yes, sir. Then n equals 0. Understand? N equals 0. So for this line, n is equal to 0. I pass through the origin. So x plus y equals 0. Next one. It says perpendicular to x plus y equals 3 and passes through the midpoint of AB. So it's going to be the line y equals x. So see it pass through the midpoint and the perpendicular to it. So it's going to pass through here. That's the midpoint. And it's going to be perpendicular to it. It's going to go right on the middle of the graph like this. Right, better. Let's show the point of 5, 5. Yes, 5. Yes, sir. 5, 5. That's going to be the line. Pass through the midpoint. The midpoint of 3, 3, guys. Must be 1.5, 1.5. So this point is 1.5, 1.5. Right? And half this distance, and also half this distance. That's where that point is. Right? So 1.5, 1.5. So that line is y equals x. That line is y equals x. That's what that line is. Now pass through everything and pass through points with x and y value the same. Line y equals x. So your calculation is obvious enough. So your calculation has to do y equals x. Pass through the midpoint and be perpendicular to this. That's it. Y equals x. So this line is y equals x. As you can see on the graph. All right. Next one. Quadratic. So the function x squared minus 2x minus 3 defined by the domain 0 to 4, negative 2 to 4, sorry. So the table below shows corresponding values x and y for 5 selected values, and I wanted to fill these two in for sure. So it's completed by inserting the missing value. So look for the symmetry now. So I see 5 out here and a 5 out here. If I come inwards to 0, then it must come inwards to 0. So right here says 0. And if you notice, if I have 0 go inward to negative 3, inward to negative 3. So this value now, we're going to have to work it out. That is the axis for this graph. We're going to have to work out this one. So this one we can deduce it. Because it must have the same value as that. See? The value between the 5 and the negative 3 over here same value between the 5 and the negative 2 over there, which is 0. So we know that this one was 0. This one is 0. It has to be 0. This one, based on the symmetry of the values. But this one now has to be worked out because it actually is the vertex. Oh no, the vertex. Because these two values are the same, right? Means that the axis is halfway between 0 and 2. The axis is halfway between 0 and 2. Halfway between 0 and 2 is 1. So the axis is actually 1. Axis at x equals 1. So right here is actually the axis, or the vertex, I should say. Well, the vertex and the axis. The axis is the line, the vertex is the point. So right here is the x equals 1. So I'm going to put the 1 in this to know what the y value is. So the y value here is going to be 1 squared minus 2 times 1 minus 3. That becomes negative 4. So right here is negative 4. And this becomes a vertex. This is the minimum point. This becomes a minimum point. Minimum point. Remember, the minimum point y value is the only y value that does not repeat. Every other y value repeats. Only at the vertex, the y value does not repeat. Because it's either a maximum or a minimum. And the maximum or minimum occurs at only a single point. All right? So that is it. So that's a minimum point. Oh, no, it's minimum, but the square term positive, so it's a minimum. All right. Next question says, on the it says on the same axis, using part A and page 15, we're going to draw this graph. Also, this graph up here, so let's draw the graph on this axis. See that? We want us to come back on this axis and draw that curve. See that? Let's do it in purple. That thing. Try to say paper. Let's draw this graph up here, so now. All right, let's put in the points. Negative 2, 5, negative 2, 5, negative 2, 5, negative 2, 5 is up here, so. Next point. Next point is negative 1, 0. Negative 1, 0 is on the x-axis here, so. Next point is 0, negative 3. That's right here. Next point is 1, 4, right? 1, negative 4. 1, negative 4 is right here. That's the axis. Then you're going to have 2, negative 3 because the value is symmetrical. You're going to have 3, 0. Value is symmetrical. They're going to have 4, 4, 5. 4, 5 is up here. The values are symmetrical. So you're going to have 4, 5. See, 4, 5. So that's the curve we're going to draw through those points. So the curve is going to go like no. Can I stretch it? Let's see if I can stretch it. Can I make it like this? Like that. And let me see. It's not a parabolic curve. Trying to see if I can just keep this curve. Bring this down a little bit. And try to see if I can get it to fit. No, it's not fitting. Let's go again. Something like and I'm sure they're going to want us to tell them now the point of intersection of the line and the curve. which are these 2 points clearly, here and there. Surely going to ask us something about it. Sorry. See? Here they said now, use your graph, complete each of the following statements. The minimum value of this occurs where x equals 1, don't it? Where x equals 1. See it right here? Right here. It's the minimum point on the graph where x equals 1. All right? It said the value of x for which this equals this. What is this now? We must realize now that this really is the line. This part comes from the line. This part comes from the line. X plus y equals 3, which means y equals minus x plus 3. That comes from the line. And this part of it is from the curve. This part of it is from the curve. So that's a curve. And that's where the line and the curve intersect. Where the equal is where they intersect. So this is asking for the point of intersection. That's what this means. When they say them equal, it means where they intersect. Where the line and the curve intersect each other. That's what the equal mean. Where the line and the curve meet. And they meet at the points where x equals what and x equals. Let's put them on. 2 points where they meet. What are the x values there? They meet at x equals -2 up here, so, and at x equals 3 right there. So see that? 2 points where they meet is x equals -2 and x equals 3. So that's what we're going to put, -2 and 3. So they meet at the points where x equals -2 and where x equals 3. That's it. Question done. Next question. Number 7, statistics. 20 bags of sugar were weighed. The weight to the nearest kilogram are as follows. It says, complete the frequency table for the data. If you notice, they give us a tally table. So a tally table is where basically used to check up the values as you check them off, you put a mark for each one. So the first value is at 3. 3, put a mark for 3. Next value is at 38. 38 to be in this group runner, so 38. Next value is 17. 17 will be right here. Next value is 33. 33 will be right here. Next value is 28. 28 would be right here. Next value is 12. 12 would be right here. 43. 43 will be down here. 38. 38 will be right here. 31. 31 will be right here. 30. 30 will be right here. 11. 11 is going to be here. 8. 8. 8 is going to be here. 23. 23 is going to be here. 18 is going to be here. 26 is going to be here. 50 is going to be down here. 22 is going to be here. Now when you reach 4, you cross it like this, just so that you reach 5 values. That's how you tally, right? Then 35. 35 is going to be down here. We're going to cross this one as well. 35. 39 is going to be here now. So we're going 6 now. Then 5. 5 is going to be one of the first one again. So we put in the values now. This is 3. This is 4. This is 5. This is 6. 5 I want to make 6. And this is 2. And that is it. We shift the tally marks over. So those are your tally marks, guys. Very good. So take them off and put in the mark for each one. All right. Next one says, for the class interval 21 to 30, that's this class interval. What is the upper boundary? The upper boundary is going to be 0.5 more than this, don't it? The halfway between this value and this value. See that? So it's 30.5 kilograms. Upper boundary is 30.5 kilograms. The class width is going to be 10. Oh, we know it's 10 because the lower limit going up by 10 consistently. sorry, the lower limit going up by 10 and the upper limit going up by 10. Don't put 30 minus 21 and put 9. That's going to be wrong. Class, which is the upper boundary minus the lower boundary. So if you want to work it out, it's going to be 30.5 minus the lower boundary is 20.5. Minus 20.5. That's how you're going to get the 10 kilograms. We should know it's 10 because the lower limit going up by 10. The lower limit is going up by 10. The upper limit is going up by 10. The class midpoint. The midpoint is the average of these two values. I could have average of the boundary values. Halfway between the 21 and the 30. So it's 21 plus 30 divided by 2. What I work out to? That's 51 divided by 2. That's 25.5. 25.5 kilograms. All right. Next question. It says on a grid on page 19, use a scale of 2 centimeters to represent 10 kilograms on x-axis and 1 centimeter to represent one bar on the y-axis. Draw a histogram to represent the data. Now remember, bars of the histogram go from boundary value to boundary value. The bars of the histogram go from boundary value to boundary value. What are the boundary values here? Lower boundary of here, so it's 0.5. And then everything going up by 10. The next boundary value is going to be 10.5, then 20.5, then 30.5, then 40.5, then 50.5. Those are your boundary values. The bars of histogram go from boundary value to boundary value. The first boundary is in here, so do 10.5, Put the marks at the boundary values. 10.5. From 0.5 to 10.5. That's the first boundary. Then it's from 10.5 to 20.5. Then it's from 20.5 to 30.5. Then it's from 30.5 to 40.5. Then it's from 40.5 to 50.5. That's where you put the bars of histogram from boundary value to boundary value. So the bar from 0.5 to 10.5 has a frequency of 3. So you're going up by 3. Then the one from 10.5 to 20.5 going up to 4 and so on, right? But all you know is that they're going at the 0.5 marks for all the values. All right, the bars of histogram, remember, they go from boundary value to boundary value. What graph there? Which graph them say on page 1? Graph on page 1. They're not giving a graph. Page 19. I don't have page 19 in this. Oh, page 19 missing. Oh, there's no page. So I give it a graph paper. So we're going to sketch one graph then. That's on page 9. I don't have any page 19. I want to insert a page. Let me see. Can I insert a page? Let's insert a page. Let's see. Where are we? We're right here. We're right here. So let's go to insert a page. Let me see. Put in a new page. Go after us. Go after us. Put in a page and draw it. Go have a draw it. I'm going to draw it right here. So I do have a graph. As my copy a graph from another past paper. Let's draw it right here. So. I want to just draw a graph, right? I'm going to scale it up like this. We can put some equal interval on it. So this is 0. Going up by 10, right? 10, 20, 30, 40. No, we shall put those in a blue. And then put the marks that they put in the values on in red. So this is 0, 10, 20, 30, 40, 50. 50 go up to don't. So it's up to 50, that's all. All right, up to 50, right? And then the frequency go up to 6. Let me see what's given to them. Say 2 centimeters to 10 on the x-axis. So you put in a 1 centimeter mark. These are my 1 centimeter marks now. And on the y-axis, them say 1 centimeter to 1 bag. 1 centimeter to 1 bag. So let's go 1 bag, 1 bag, 2 bags, 3 bags, 4 bags, 5 bags, 6 bags. I think the highest number of bags was 6. Right, 6. So 1, 2, 3, 4, 5, 6. Okay. All right. Remember now, the key thing is that the bars of the histogram one is 0.5, right? So I'm putting these little marks for the 0.5. So that is like 0.5. It's like 10.5, 20.5, 30.5, 40.5, 50.5. That's where the bars go, right? 0.5, 10.5, 20.5, 30.5, 40.5, and 50.5. Those marks, right? Those marks right there. That's where the bars go, right? But the first one has a frequency. What are the frequency values again? We copy these down. So we're going back and forth. Copy these down. Those are the frequency values. The first one has a frequency of 3. Put them over here. First bar had a frequency of 3. So you're going up to 3. So you put a bar up to 3 here, so the 10.5 mark. For the first bar, frequency is 3. Next bar has a frequency of 4. So next bar goes up to 4. So you extend this side up to 4. I carry it up to 4 as well. And then join them at the top here, so that's 4. Next one goes up to 5. So extend this up to 5. Extend this up to 5. Join them at the top. That's 5. Correspond to this 5 right so. Next one goes up to 6. So extend this up to 6. Carry this all the way up to 6. And join them at the top. That is 6. The next frequency is 2. So drop it down to 2 now. So 2 here, so 2 across the sun. So right across this is 2. So we're not to do it like this. So come across here, so come up to 2. And let's go right there. 2. That is the histogram. That's an easy. Alright? And label it up. That's a histogram. So what are the scores again? Up here were your bags, right? Bags. And down here was the weight. Down here the weight. Kilogram. So the number of bags. Number of bags. That is your histogram. That is it. Very good. All right. Take these out. Can't stay put, man. Can't stay put. Sit down, man. Walk one on too much. Next question. All right, this question. So this question, let me tell you something I remember about it. Every time I come on this question, I remember a student that was in this class. Right? She get 1 is straight A's. And she actually taught the Caribbean in advanced and pyramids after she did CSEC in fourth form. But the year when she did this exam in 2016, May, and this question gave her problems. You know why? Because she was looking for a formula line. And there was no formula line in this question. I always remember I said there's no end line on the question. But with the practice all the question, then to come up with a formula for each time, that's the method we practice. But there's no formula line on this one. Right? But what I said to her is that the question only went up to 10. So if you pick up the pattern of the number, just continue it up to 10 and that's it. Just work it out on yourself. So they give you up to 4. If you can't pick up the formula, right? You come up to 4, just pick up the pattern, you just go up to 5, then do the one for 6, do the one for 7, do the one for 8, do the one for 9, and do the one for 10, and you're done. You have the whole day, spend the whole time and try to come up with a formula. You understand me? So if you can't come up with a formula and they give you just up to 10, you cannot work it out up to 10. Just pick up the pattern of the shape, what is happening, and carry it up to the 10th one. And just fill out the ones, you will see which one corresponds to that 255 there. Put in the values for that one here. And then you see which one corresponds to the 10. Just continue the pattern of figures. Right? So I always remember that student that year. Right? But let's look at it. Because we can develop a formula for it as well. Because we did look at all the possible formulae that they would give you. I tell you that you must look out for them. No, sir, you don't look for none, no. You don't look for none. Anyway, let's go. So this is the shape that I give. And if you notice, what is happening? They keep adding one of this thing, the one that with 2 strings on it, onto the end, right? Onto each end, right? That they end up with. So if there are 4 ends, they add it onto the 4 ends. So from 4 ends, you double that to 8. So you have 2 ends first, you double that to 4. From 4, you're gonna double 4 to 8. From 8, you're gonna double that to 16. 16 going double to 32. 32 going double to 64, and so that's how many ends you're gonna have. And then on each end, you're putting on 2 additional strings and 1 dot. So you put on 2 dots first, you're putting on 4 dots. So you're gonna put on 8 dots next. You're gonna put on 16 dots, and then for each dot that you put on 2 strings. For each dot that you put on, you're putting on 2 strings, don't you? That's all? You can pick up the pattern based on that. So the question says, they give us that each figure is made up of knots and strings. Each knot is connected to 3 strings, right? But what they are adding is this. They're adding a dot and a knot and 2 strings to each end, all right? At the end of each string. So to draw figure 4, you just have to draw this one and then add on this thing onto each end, don't it? Now I have the device. So I'm going to use the device. Osh. I'm going to use the device. I'm going to copy this figure 3 here. So as I have the device, might as well I use it. And I'm going to paste it right here. As I have the device, makes sense I use it, don't it? I can't be like you guys. You don't have no device to do this thing. I have it, I'm going to use it. I'm going to cross out this figure 3 thing right there, so. Let's cross out this. I can do it because I have the device. And then I add on in blue. Right? So on each end, I'm adding a knot with 2 strings, don't it? So here I'm adding a knot, 1 string, and another string. A knot, 1 string, and another string. A knot, 1 string, 1 string, and another string. A knot, 1 string, and another string. a not, one string, and another string, a not, one string, and another string. A not, one string, but oh, she had to draw by everything, right? So, but see, I do that in the morning. Then let's get they would give it out the third diagram and add and quick. And what I've seen them do, they give the third diagram and left off some part of the third diagram. They fill out the missing parts and then add on to make the fourth diagram. All right, that's it. Then we come to the numbers now. Here below shows the number of knots and strings in each figure. Used to draw figure 1, 2, and 3. Complete the table by inserting the missing values in each row numbered 1, 2, and 3. All right. So here you realize that they added 2 knots first. They're going to add 4 next, don't it? They're going to add 8 next, don't it? That's all. They're going to add 16 next. If I were in the exam and I can't get a formula, that's what I do. Right? But I can write a formula for you. Because remember, when you keep doubling, it's a 2 to the n relationship. Okay, keep multiplying by 2. So that's 2 to the n. So the formula done with 2 to the n. But the first figure only has 1, so we'll subtract 1. You can test it. 2 squared is 4, 4 minus 1 is 3. Test it yourself. 2 cubed is 8, 8 minus 1, 7. That's the formula for this column right here, so. And then over here, so now, what's happening over here, so? Over here, so now, relate to this formula, because for every knot, there are 2 strings, don't it? For every knot, there's 2 strings. So it becomes 2 times this, 2 strings, plus 1. Because there's the first string that I started with. So it's 2 times this, plus 1 you do it. So over here would be 2 times this, plus 1. And you can check it. So if you multiply out this now, it becomes 2 times 2 to the n. 2 times 2 to the n minus 2 plus 1. So it becomes 2 times 2 to the n minus 1. Yeah, so you can try it. So when the n is 1, you get 2 to the 1 is 2. 2 times 2 is 4. 4 minus 1 is 3. See that? When n is 2, you get 2 squared is 4. 4 2 is 8. 8 minus 1 is 7. See that? When n is 3, you get 2 cubed is 8. 8 2 is 16. 16 minus 1 is 58. See that? So this becomes the formula for that rule. But you don't have to reach the formula. I don't expect to go and figure out the formula in the exam. You could, but if you don't, that this would be a formula for it. Now, how would I do to write a formula? I have to put in all the values until we get it. Right? So I'll go in the exam room. If I'm in the exam room, I know that this is the next shape. So here, they did a plus 2, then plus 4, but we're plus 8 now, don't it? That's all. So 8 and 7 is how much? 7 and 8 is how much? 15. 8 and 7, 15. And you can check if 15, if figure 4 is 15, that's for true. You can check it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. See that? Then up here, so what's happening with the strings? You add 4, then you add 8, and then you add 2 times that, you add 16. Add 16. So 15 and 16 is how much? 31. You have 31 strings. Eh? So you can check it before on the formula. So it's 2 to the 4th power is 16. 16 times 2 is 32. 32 minus 1 is 31. Right? So if I'm in the exam, I'm going to get the formula. You just follow the pattern until you reach 10. Just put that down yourself. Follow the pattern until you reach 10 down yourself. That's what I would do in the exam room. If I can't come with the formula once we have the time. Just follow the pattern. So see it here now. But if you notice, look at what you notice again. It's whatever I added here, same figure I add up here. So the next figure I add 16. And the same figure I add over here. So see that? That's also another thing you notice because you're adding twice as much on the string as well. So if I'm in the exam room, I'm going to just do a little table down here for myself and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Put him a little end column so for myself. I can open a formula. I put him a key column right so. I'm going to start out. 1, 1, 3, 7. Right? So, and then I write over me have to add beside it so now. I have to add beside it so. Add. So for this one, I start with 1, I add 2, then I add 4, I have to add 8, then I have to add 16, I have to add 32, then I have to add 64, then I have to add 128, then I have to add 128 is what? 256, 256. Then I have to add how much so now? 512. 256 times 2 is how much? 512? 512. See that? That's my key. So this is what I have to add now to get my key values. If I'm in the exam, I'm gonna do that. Because I can't figure out the formula. That's what I'm showing you what I would do in the exam room. Once we have the time, then we have the S now, the strings. The strings. And the string started out 1, 3, 3, 7, 3, 7, 15. 3, 7, 15. But this kind of easy because I realize now that this number is here. So see that? See that? That number is here. So if I fill out this column, we just can't fill out that one. So let's fill out this column now. I'm in the exam. So I'm add 8 to this now. 7 and 8 how much? 15. Add 16 how much may I get now? 31. Then I add 32 how much may I get? 63. Then I add 64 how much may I get? 127. Then I add 127 how much may I get? I get 1 value less than this. Notice? Was that as well? I'm getting 1 less than this. This is 1 less than this. So I get 255. And then I get 1 less than this. How much is that? 511. The next value for add is 512 to this. How much may I get? 1023. And then we'll figure that this figure is right here, so it's a 31. And the figure is right here, so it's a 63. The figure is right here, so 127. The figure is right here, so 256, 255, sorry. The figure now is right here, so 512, 511, sorry. Figure here is just right here, so which is what is that? 1023. Then we have to add what the next one. What would I add after this one? The next one would have been 2 times we have to add this again. 2 times this one for add. 2 times this. That's 1024. 1024. Right? We have to add to this. So that figure comes right there. So the next one would know we have to add this to this. So it would have been what? If I add this to this, so I'm gonna get 2 2 0 2 0 4 7. Also, so it's a 2047. Those are my figures. So this is my root 10 right. So if I'm in the exam room, I'm just add it up like that. Right? And the row that corresponds to the 255 is this row right just so. So that's but can't figure it out. So this is over is 250. This is 7, and this is 127. And the row that is 10 is 1023 and 2047. Let's test them in a formula. So when this is 10, 2 to the 10 power minus 1. 2 to the 10 power is 2 to the power 10 minus 1. See? Oh, not that. 2 to the power 10 minus 1. You get a 1023. See there? 1023. And then if you use a formula, it's 2 times 1023 minus 1. 2 times the 1020. No, sorry. 2 times 2 to the power. 2 times 2 to the power 10 minus 1. Let's go. So it will be 2 times. So you get 2047. Yeah? 2047. So if I'm in the exam room, guys, and it's not a formula one, and a small number they give me, let's work them out. Let's work them out. You can't figure it out, let's work them out, especially when just 10 they give you. Like that. You get me? You can get the formula, fine. But if you can't get the formula, let's work them out. You have time. Remember, you have 15 minutes for the question. You know? You have 15 minutes for the question. Normally, the question can be completed in 10 minutes or 5 minutes. But if I give you one and you can't figure out the formula, right? But then I give you all the possible formula that you have to consider. I gave you them, you know, so look out for them. I gave them to you. All right? Chance I get one straight forward, so don't worry yourself. But that is it. It happens. All right. So that's what I would do in the exam if I was in that situation. I can't get the formula. Let's work them out. Next question says, f and g are these two functions. I want us to find f to the minus 1 first. Let's go. F to the minus 1 that was. I'm going to say f equals 2x minus 7. Inverse it, x becomes 2 times f to the minus 1 minus 7. To make this subject, I'm going to cover the 7 and divide under the 2. So I'm going to get x plus 7 over 2 equals f to the minus 1. That is f to the minus 1 of x is x plus 7 over 2. Done. Then I want g to the minus 1 next. G to the minus 1. So I'm going to say that g equals x squared plus 1. Inverse that, the g becomes x. The x becomes g to the minus 1, but it is squared plus 1. I'm going to take the positive square root. Bring over the 1, we're going to get x minus 1 equals g to the minus 1 squared. To get rid of the square of a square root both sides. So we're going to get the square root of x minus 1 equals g to the minus 1. That is g to the minus 1 of x is the square root of x minus 1. All right? Taking the positive square root. Next one. F of g. F of g means g into f, right? So the f, remember, is the f is 2x minus 7. And the g is x squared plus 1. The f of g means the g into the f. G into f. So taking this g, put it into the f right there, where the x is. That's how construct the f of g. Therefore, f of g of x becomes 2 times bracket x squared plus 1 minus 7. So it becomes 2x squared plus 2 minus 7, right? Because the 2 times 1 is 2. 2 minus 7 is negative 5. Minus 5. That is it. That's f of g. Then I want fg to the minus 1 now. So we have to inverse this now, right? Fg to the minus 1. But you could use this now. You could say that you could do this now. You could say, okay, fg to the minus 1 is g to the minus 1 of f to the minus 1, and you could do that now. Okay, you should know that fg to the minus 1 is equal to that. So do it that way there. Right? So you could do it that way. I work it out. I put in the G F to the minus 1 into the G to the minus 1 like that. Use your knowledge where you have. Right? So let's see. The G to the minus 1 is what again? Let's put them over here in purple. The G to the minus 1, remember, is square root of x minus 1, square root of x minus 1. And the f to the minus 1 is what again? Is x plus 7 over 2, right? I'll put in this one coming inside here, where x is. That's how we put the g to minus 1. F to the minus 1 to the g to the minus 1. Let's do that. So note, guys, note that when you have fg in here, you put g and f in the opposite way around here, outside, where you inverse them. You see that? So it's good to know this and use it. Right? It's good to know that and use it. So just work it out that way, though, rather than to calculate it straight. I can calculate it straight and show you still, because you'd have to inverse this. You'd have to inverse this thing. You're going to get the same one. Let's just do it that way as well, right? But let's do it this way first. So this would work out to be equal to the square root, where the x is, I'm going to put x plus 7 over 2 and minus 1 beside it. That's the answer. Quick and fast. Right? That's the answer. Or, let's do it the other way. Or, we could say the fg is equal to 2x squared minus 5. 2x squared minus 5. And we invert. We'll have to work out what this is to show that it is true, right? We'll have to work out inside here. So put this as 2 over 2. So put this as 2 over 2, it will be equal to, put a different color, Mr. Shaw. This would be equal to, this is the same as square root as 2 over 2. 7 minus 2 is 5. It's equal to same as x plus 5 over 2. This thing is the same as this. So we'll invert this one, and that way we're getting. So we're inversing this now. Watch. This becomes x. It becomes 2fg r to the minus 1 minus 5. This is subject now. Well, or the squares on it as well. Squares on this. It's kind of complicated in that way. So maybe we need to use the y and x method here. So when I put the y equals 2x squared minus 5. Don't inverse it yet. Right? So when inverse it, write this as a y. Make it less complicated. So it becomes x equals 2y squared minus 5. I want to make this y the subject now, which is now the inverse of this composite function. So I'll carry over the 5 and divide on the 2 first. So you get x plus 5 over 2 equals y squared. And you square both sides. So from here now, you're going to square both sides. You're going to get the square root of x plus 5 over 2 equals the y. And the y is the inverse of this function. Right? So therefore, fg r to the minus 1 will be equal to the square root of x plus 5 over 2. So this is the OR method on it first. But I think it's easier to do it that way, as you can, using what you know already. You know that the inverse of a composite function equal the composite of the inverses when you flip them around. Alright? But this is the OR method on this. Alright, next part down is now show that this equals that. Show that that equals that. So we'll plug in the 5 on both parts. So work out this and work out this and show the two of them are the same. That's what they want us to do. Let's see here now. Fg to the minus 1 of 5 means that we're putting 5 in this. So it becomes the square root of 5 plus 5 over 2. Becomes the square root of 10 over 2, becomes the square root of 5. Equals the square root of 5. As is 10 over 2, which is 5, right? Square root of 5. They want to work out this one. So g to the minus 1 of f to the minus 1 of 5. They're going to do the f to the minus 1 of 5 first. So it becomes g to the minus 1 of. Now, what is the f to the minus 1? Let's put them over here. Remember that the f to the minus 1 was, what was it again? X plus 10 over 2. X plus 7 over 2. And the g to the minus 1 is square root of x minus 1, right? Square root of x minus 1. Square root of x minus 1. So we're working out this part of it first with this. So it becomes 5 plus 7 over 2. 5 plus 7. Put it back in blue, Mr. Schwartz. Becomes 5 plus 7 over 2. 5 and 2 are 5 and 7 are 12. 12 over 2 is 6. So it becomes g to minus 1 of 6 now. And in g to minus 1 of 6 now, we're going to put 6 here. So it becomes square root of 6 minus 1, which then is square root of 5. So you see, two of them give the same thing, root 5. That confirms it. That one give root 5. So we can say, therefore, based on all of that, based on these two things, you can say shown that fg r to the minus 1 of 5 is equal to g to the minus 1 of f to the minus 1 of the same 5. They are both equal to the square root of 5. That is what we show. Right? That is that. All right. Next question. That's a distance time graph. Remember, on a distance time graph, it shows where you are from a reference point. Not meant to show distance travel. And remember, gradient on a distance time graph is speed. Gradient is speed. And let's see what this one says. It says the distance time graph below shows the three-stage journey of a car traveling from town A to town C and back to town A. So once you're on this line, the distance is 0 because you have town A. All right? Up here says town C. So town C is 100 kilometers away from town A. And I guess maybe this is town B right here. So when it stops, 40 kilometers away. Let's assume that. And that's what it says. It says, state the time of day at which the car arrives at town C. So you said 6 o'clock in the morning. It's when it arrives at town C. Right, that's all. When it just arrived at town C, right? Town C is 100 kilometers away. So this is when it arrives at town C. What time is that? That's at 8:30. Halfway between 8 and 9 is 8:30, don't it? So that's at 8:30 when it arrives at town C. Put a line on it. So you said when it arrives at town C. 8:30. All right, 8:30 a.m. Next one, calculate the total time in minutes for which a car stopped during the journey. It stopped, yes, sir, and it stopped, yes, sir, don't it? 2 times it stopped. When it stopped, the distance not change, right? So this is a stop. Let's call it stop 1. It's a stop 2. So stop 1 time was, how long is that? That's 30 minutes, right? Based on this, 1, 2, 3, 4. 4 intervals in that. So each interval is 15 minutes. Can you see that? Don't it? See that? 15 minutes. So this was 30 minutes and that's 15 minutes. That's right. Stop 1 was 30 minutes. Stop 2 is 15 minutes. So the total stop Stop 1 plus stop 2. It's 30 minutes plus 15 minutes equals 45 minutes. So total time is stop was 45 minutes. So determine the constant speed of a car during stage 2. Speed equal the distance over time or the gradient. Right? Then stage 2, the distance in stage 2, I can say stage 2 equals stage 2 distance. Stage 2 distance. Stage 2 distance, Mr. Shaw. Stage 2 distance over stage 2 time. What's the stage 2 distance? Stage 2. Stage 2 distance is from 40 up to 100 at 60. 60 kilometers, don't it? So stage 2 distance is this. 60 kilometers. And stage 2 time is this. And how long is that? 30. 1 hour, don't it? 1 hour. So it's 60 kilometers per hour. See that? 60 kilometers per hour. So that becomes equal to 60 kilometers over 1 hour. So the speed is 60 kilometers per hour. What's the average speed? That's an easy, right? 1 hour. 1 hour. That's 30 minutes and 30 minutes. 1 hour. All right. That's stage 2. All right. Next part says, calculate the average speed of the car for the time during which it was moving. The average speed for the time which it was moving. That's the total distance divided by the total time minus the stop time, right? For the amount of time it was moving, right? So that's for the whole journey. So that equals the total distance over the total moving time. Well, the total moving time is the total time minus the 45 minutes we stop for, don't it? What's that? And 45 minutes is 3/4 of an hour. So we can give it in hour, right? 45 minutes is 3/4 of an hour. Let's put it here, sir. They want it in minutes up here. Let's put the 3/4 hour. This is 0.75 hours. 0.75 hours. An hour. 0.75 hours stop, all right? Now, the total distance we travel is how much? Who can tell me total distance we travel? What's the total distance we travel? You go all the way up to town C first, up to C, which is 100 kilometers away. And then you come back to 8. You come back to 8, so. See that? So the total distance traveled was 200 kilometers. 100 kilometers away. We reach up here, so. See, come back there, so. Come back to A. So the total distance traveled is 200 kilometers. Remember, the graph only show you distance where you are from a reference point, you know. So when you come up here, so, it was 100 kilometers away from A. And then down the when it came back to A, you see that? So the total distance traveled is 200 kilometers. 100 kilometers to go, 100 kilometers to come back. It's total distance traveled. Right? So it traveled 100 kilometers away plus 100 kilometers back. 100 kilometers away plus 100 kilometers back. Divided by, what is the total time? total moving time. Total moving time is total time minus 45 minutes it stop for. How long is this total time? 4 hours that, don't it? That's all. And it stop for 45 minutes, 3/4 hours. That's all. So the total moving time, let's write it down there. The total moving time. Total moving time equals 4 hours minus 0.75 hour. So moving time is 3.25 hours. What does that mean? That stopped for 45 minutes, which is 3/4 of an hour. So it was moving for 3.25 hours. See, the total time from 6 hours to 10 hours is 4 hours at 10 hours. Total time is 4 hours. Total time. But in that 4 hours, it stopped for 45 minutes. And I want the average speed when it was moving. That's what Christian said. The average speed for when it was moving. So the total distance was 100 kilometers away that it went, and 100 kilometers that it came back. So that's 200 kilometers divided by 3.25 hours. See here, divided by 3.25 hours. I read that 200 divided by 3.25. Get kilometers per hour. Huh? 61.5 exact. So give them the exact value for that again. 61.5 kilometers per hour. Give them that. So it's 200 divided by 3.25. Oh, next up. I was wondering. 61.5 is good enough. 61.5 kilometers per hour. That's it. All right, next question. Number 10. Number 10 said diagram below that transition shows a circle center O, and those are two tangents. Two tangents from a single external point. It's two tangents from a single external point. Question this. Long time I don't see one like this. All right, those are straight lines, and the middle hand side it says 44 degrees. Remember, these two angles are up to 180, right? Right? Those two angles are up to 180. Remember that this thing with the two tangents and the two radii is a side quadrilateral because the angle here says 90, angle says 90. So these two angles are up to 180, and these two angles also are up to 180. Remember that for a side for that two tangents. It says, calculate given reasons the measure of angle EHF. EHF. All right. So the thing now for EHF is that these two lengths are the same, right? So this is an isosceles triangle, don't it? And if that's an isosceles triangle, means that these two angles equal. This angle, that I want, and this angle equal, right? So this angle that I want becomes 180 degrees minus 44 degrees divided by 2. Agreed? That's 90 minus 22. 90 minus 20, 70 minus 2 more is 68. 68 degrees. Agreed? That's 68 degrees. So it is 68 degrees. I will get it. Huh? Yeah. We get it by doing 180 degrees minus 44 degrees divided by 2, 68 degrees. And the reason is that that triangle is isosceles, that the two tangents are the same length. Right? So the two tangents are the same length. So I want to tell them that triangle EHF is isosceles. And the isosceles, the total angle is 180 degrees, right? That's the premise on it. Then I want angle FGH. 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 That's the angle up here, the one. Now that angle that I want is subtended by this chord. See that? And the chord is making this 68-degree angle with the tangent over here. This is 68. Angle between the tangent and the chord will always be equal to the angle subtended by the chord. See that? So that angle here is also 68 degrees, right? Tangent and chord rule. So that angle is 68 degrees as well. Right? So that angle is 68 degrees as well. This angle equals 68 degrees. Reason because angle between tangent and the chord equals angle subtended by the chord. That's why it is 68 degrees up here. Let's write it. These angles are all 68 degrees. So this one is the calculation, 68 degrees. This one is 68 degrees. That makes this one 68 degrees. All right, so everything so far is 68 degrees. 90 minus 22. All right. Then I want angle JHE, 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 JHE. That's 90, right? Angle JHE is angle right here, so between this, I'm going to draw it in red for you. So you can see it. Angle JHE. J to H to E. That's angle between this radius and this tangent. That's 90 degrees. Right? Angle between tangent and radius is 90 degrees. So this angle is 90 degrees. Angle between tangent and radius is 90 degrees. That's it. Next angle I want is JGH. JGH. Don't put in the red 90 degrees here. So this angle here says 90 degrees. That's just between these two lines, 90 degrees. All right, JGH. JGH. That's a 92. JGH, I'm going to say JGH. JGH. JGH right now is subtended by this chord, this diameter, I mean. I'm subtended by a diameter at 90 degrees. So that red angle up here says 90 degrees as well, up here, so. Subtended by this diameter. I'm subtended by a diameter at 90 degrees. So that angle also, that angle is 90 degrees as well. This angle is 90 degrees. Angle subtended by a diameter is 90 degrees. That's it. Done. Come to this question now. It's an elevation question. So I gave you this paper for a long time. We don't do an elevation question. Question says, diagram below not drawn scale shows two ships R and S at anchor on a lake of calm water. Means that they're not moving. It says FT is a vertical tower. That's a vertical tower. And FSI is a straight line. So that's a straight line. And RS is 150. That's the distance between the two ships, 150. Angle of elevation of T, the top of the tower from R and S are 22 and 40 degrees respectively. See them here, they give them. So it's angle looking up, angle looking up. They give those two angles. Nice and easy. All right. Respectively. It says F is the foot of the tower. F is the foot of the tower. I want us to calculate the 1 decimal place, the measure of angle RTS. RTS. That's this angle up here. So easy. Remember, I told you. Good. All right. So that this angle out here will always be equal to these two. Sum of those two. I gave it that. That angle over here is equal to the sum of those two. But an exterior angle is equal to the sum of the two opposite interior angles. So this angle over here so will always be equal to the sum of those two. All right? So I press. Because if you look at this triangle here, this is an external angle over here out here. So that external angle or exterior angle is equal to the sum of the two opposite interior angles. So these two angles add up to 40. Then the one up here that I want is 40 minus 22. But I can say that 40 minus 22. So this angle that I want is 40 degrees minus 22 degrees. How much is that? 18? Huh? That's 18. 18 degrees. But go to that. So this equals 40 degrees minus 22 degrees. 18 degrees. All right, that is it. If you want to, you could find this angle first. Total angle Australian is 180. It should be 140 degrees. And then total angle in the triangle here, so now is 180. See that? We do that as well. All right? So you end up with the same thing. Anyway, next thing I want is the length of ST. The length of ST, which is this length. So to get that length, we're going to work in this triangle and use sine rule. Why are we using sine rule? Because we have this pair of angle and side opposite each other. I want to use it with this pair across here. So I'm going to use sine rule in that triangle now to find ST. Sine rule for ST. Let's try it. Sine rule. So it's going to be ST over the sine opposite the ST, which is the 22 degrees. ST over the sine of angle opposite to it. So ST over the sine of 22 degrees equal the side that you know, the 150 over the sine of the angle opposite the 150, which is the 18 degrees up here, or the sine of 18 degrees. And the ST, you know, you find ST by taking the sine 22 and multiply it up here. The sine 22 and multiply it up here. Make this a little smaller. Space kind of small to work in. So therefore, SE becomes equal to 150 and the sine of the 22 degrees. We'll take this and multiply it up here. I will put it behind the number divided by the sine of 18 degrees. Roll that out with the calculator and you will have your answer. Split the screen since we're doing a calculator question. All right, so we're doing this calculation. Fraction 150 times not 160, 150 times sine of 22. I put that over sine of 18. I'm getting 181.8. One decimal place is 181.8. What is that in meters, kilometers, meters? 181.8 meters. So this length now is 181.8. 181.8. Let's put that in red to work it out. No matter. 181.8 meters. Can work in this triangle and use so-called tower. Right? Now I want the height of the tower. So I'm going to work in this triangle now. I want to find this opposite side to this angle. So when I say sine of 40 equal the opposite side over the hypotenuse. That's what we're going to use now. Sine of 40 equal the FT, the height of the tower over the hypotenuse, 181. Let's do it down here. So we're going to say sine of 40 degrees. Sine of 40 degrees equals the FT over the hypotenuse, 181.8. So I'm going to take 181.8, multiply it up here now, and that's going to be the FT. And so the FT is going to be 181.8 times the sine of 40 degrees. I wrote that out. Therefore, FT equals let's work it out. So it's going to be 181.8 times the sine of 40 degrees. That's 161.9. 116.9 meters. Done. That's what a nice easy question. Nice and easy question, that one. All right. All right, next question. Last one. All right, vectors. So the portion vectors of A, B, and C relative to an origin O are those things. A, B, and C. It says find the vector AB in the form column vector format. That's OB minus OA. O times the last minus O times the first. So it's this one minus this one. What is that? Equals 6 minus 2 is 4. 1 minus a negative 2 becomes 3. Minus minus a plus, so you get 4, 3. But I give it that. Then AC is just OC minus OA. So now we're doing this one minus this one. So ready. 10 minus 2 is 8. 4 minus a negative 2 becomes 4 plus 2 is 6. And then two vectors are parallel. But see there, one is a multiple of the next. The big one here is 2 times the small one there. So then parallel. You can see that from those numbers easy. All right. And also is a common point. So they're actually collinear points. So the points are collinear, but it's a common point. So a parallel vector is a common point. It says, hence determine whether A, B, and C are collinear. Yes, they are collinear. So you're going to say, okay, the big one AC, you can see it in the numbers. You know. I don't have to do nothing with this because it's a 2 times this, obviously. This one is 2 times this one. So the big one AC is 2 times the small one AB. Which means that they are parallel and have a common point. So 2 things happening here. 1, AC is parallel to AB. That's the first thing I need for collinear points, parallel vector. Second thing for collinear points, must have a common point on the 2 vectors. So there is a common point. A is a common point. A is on both vectors. And once you have those 2 things, you can draw the conclusion. Therefore, A, B, and C are indeed collinear, meaning that they are on a straight line. Because these 2 things happen, the points are pole. That is it. But good? 3 marks for that. Next part says, determine the value of X if that matrix is singular. Now, singular means has no inverse. Right. Singular when it has no inverse, the determinant of the matrix is equal to 0. The determinant equal to 0 as well, AD becomes equal to BC, meaning this product, that first diagonal product becomes equal to the second diagonal product. That's what we're going to use for the purpose of calculation here. So we're going to say that the 3 times 4 becomes equal to 2 times x. 2 times x. Now this 3 times 4 is 12. In order for it to be 12, to the x has to be 6. Therefore, the x is equal to 6. That is it. Two diagonal products must be the same when it's singular. When we subtract them and get 0. So x is 6. Are they good? Nice and easy. Next part. N and P are two 2 by 2 matrices. I want us to multiply them. I want us to multiply these two matrices. We're going to go through the process. So it's 4, 1, 3, 2 times 1, 5, 2, 1. When we multiply the matrices, we multiply the rows of the first matrix by the columns of the second matrix. So using these two rows, multiplying by those two columns. All right? So now, when we multiply those two, we're going to get a big 2 by 2 matrix. 4 values. 1 here, 1 here, 1 here, 1 here. First one here is positioned in the first row and the first column. So to get it to multiply this first row by this first column, how multiply them? First element times first element, second element times second element. First element in the row and the first element in the column, second element in the row by the second element in the column. So it's going to be 4 times 1 and 1 times 2. 4 times 1 is 4 and 1 times 2 is 2. You can write down over here so from now. This equals, this value becomes a 6. Then we come back. Is it this value now, which is positioned in the first row and the second column. So the multiplier we use in this first row with the second column. So it's first element in the row and the first element in the column. Then second element in the row, second element in the column. First element times first element, second element times second element. First element times first element, second element times second element. 4 times 5 and 1 times 1. 4 times 5 is 20. 1 times 1 is 1. So that becomes a 21 over here, so right? 21. Then we come back now to this value down here, which is positioned in the second row and the first column. So to get it to multiply this second row with this first column, first element times first element, second element times second element. First element times first element, second element times second element. 3 times 1 and 2 times 2. 3 times 1 is 3, and the 2 times 2 is 4. That value 3 plus 4 is a 7 right here. Then we come to the last value out here, which is positioned in the second row, second column. So to get it to multiply this second row by the second column, first element times first element, second element times second element. First element times first element, second element times second element. 3 times 5 and 2 times 1. The 3 times 5 is 15, and the 2 times 1 is 2. 15 plus 2. 15 plus 2 is 17. That value out here is 17. That's the answer. It's really one more to give for that. Wow. Wow. See one mark for everybody. Next question. Give me that Pn is equal to this. See, Pn is different from Np. I remember this is Np. This is Np. Determine whether matrix multiplication is commutative. No, we know it is not commutative. So we're gonna say since Pn is not equal to, this means not equal to Np. Matrix multiplication is not commutative. Remember, commutative means that when something is commutative, when you reverse the order, the result is the same, like addition. 2 plus 3 is same as 3 plus 2. That's commutative. I get the same result. Multiplication of real numbers. 2 times 3 is 6. 3 times 2 is still 6. So the multiplication of real numbers is commutative because when you reverse the order, the result is the same. But for matrices multiplication is generally speaking not commutative. When you reverse the order, the result different as you can see here. Not the same matrix. Not the same result. All right? That's it. Next one, determine n to the minus 1. What was n again? N was this guy right here, right? 4132. 4132. So n is 4132. Another one, the inverse of that n. So remember, n to the minus 1 is 1 over the determinant of n times the adjoint of n equals 1 over. The determinant is this product, first diagonal product, minus second diagonal product. First diagonal product is 4 times 2 is 8, minus second diagonal product is 3 times 1 is 3. Times the adjoint matrix. How do the adjoint? Interchange the elements on the first diagonal. Interchange them. So 2 goes here and 4 goes there. The elements on the second diagonal are going to leave them where they are, change the sign. So this negative, this one stays where it is and becomes a negative 1. This 3 stays where it is and becomes a negative 3. Know that this under here now is a 5. This is actually a 5. 8 minus 3 is actually a 5. The determinant is 5. So now you're going to divide each of those values by the 5 to get the inverse matrix. So that becomes equal to 2 over 5 minus 1 over 5 minus 3 over 5 and 4 over 5. That now is your n to the minus 1 matrix. N to the minus 1. To the minus 1. If you have used n to the minus 1 in any calculation going forward, use this one with the 1 over 5 outside for last. Leave 1 over 5 outside for last. Which is what they wanted to do right here. See? It says, hence, take the value of x and y where this time is equal to that. Note that this is actually the n. Right? That is actually the n matrix right here. So, this is n times xy. N times xy equals 1, 2. And therefore, you want to find the xy, you're going to put inverse of in front that. So the xy is going to become equal to n to the minus 1 times 1, 2. Complete with that calculation. That's what we're going to do over here. So the xy that I want is going to be n to the minus 1. We're not using this fraction one. We're going to use this one, 1 over 5 times that. So the n to the minus 1 is 1 over 5 times this matrix, 2 minus 1 minus 3, 4. That's what that joint. And then multiply by the 1, 2. Multiply that by 1, 2. All right. So we're doing this calculation here first with those two matrices. Same thing again. Using the rows of the first matrix with the 1 column. All right. So it's going to become equal to 1 over 5 and the column matrix, 2 values. 1 here, 1 here. So the first value here is in the first row and 1 column. So multiply this first row by the 1 column to get it. Same thing again. First element times first element. Second element times second element. First element times first element. Second element times second element. 2 times 1 and minus 1 times 2. 2 times 1 and minus 1 times 2. That's like a 0. 2 times 1 is 2. Minus 1 times 2 is negative 2. That becomes a 0. Second value is position. Second row, 1 column. Second row, 1 column. First element times first element. Second element times second element. Minus 3 times 1 and 4 times 2. Minus 3 times 1, 4 times 2. Minus 3 times 1 is negative 3. 4 times 2 is 8. Plus 8. This becomes equal to 1/5 of 0, 5. But the 8 minus 3 is a 5. Final answer. 0 divided by 5 is 0. 5 divided by 5 is 1. So your xy is 0, 1. Your xy 0, 1. So from this, you draw the conclusion. The x is equal to 0, y is equal to 1. And this is your answer right here. End of this test. And that is that. Is that. I need to hear some scores before you go. That was a nice paper. That was a nice paper. Nice little paper right there. See the solution here. Let's see this solution. See this solution. I'm gonna get everything. I'm gonna get in there. Oh. All right. That. Jadi, how much I get? Let me check. Jadi, how much I get? Jadi, online, how much I get? How much I get? Huh? Hello? 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 Yeah? I'm gonna tell us, yeah, I'm gonna send an email by itself. Send an email yesterday. But I remember it's a combination of the end of the month and the beginning of the month. Yeah, I'm gonna tell you something. Oh, yeah, check it email. All right. That is okay. Yeah. Circuit theory. So work on it. Again. Yeah, sure. Huh? So do it go for left to tip when I'm other book. But based on what question. The team structure. Huh? It. Oh, now go on, man. Now go on for a paper yourself. That is it. All right. Come again. Oh, come here, you must shoot it. You doing it? You doing it? Oh. Why are you missing my math exam then? I'm beat you to do this weekend. Don't miss no more. Hey, we're doing maths all day Saturday and all day Sunday here. All day Saturday and all day Sunday, remember. Jadi, how much again? Hold on. Hello? Listen now, I'm soon call. I call it a bit. Well, yeah, man, cool. Come here. Oh, you send out your paper. All right. I'm gonna end the session now.